Hello there again. We are now doing section 4, chapter 2, Algebra Dose. And we are going to talk about two separate forms of the equation of a line. We already discussed in 2.2, I believe, we discussed standard form, ax plus by equals c. And now we're going to talk about slope-intercept form and what we call point-slope form. And I want to tell you that they actually come from the same slope formula right here. And so if you take any two, if we want to take this formula right here, for example, we can actually manipulate this little guy. And if I were to multiply because I feel like it, you're probably going to say, well, I don't want to multiply. Well, you know, just do it. If I multiply both sides by the bottom portion of the formula, what's going to happen is that this x2 minus x1 is going to cancel with this one over here. And what you're going to have, if I write this in a different order, is I'm going to get y2 minus y1 equals m times x2 minus x1. And believe it or not, this pretty much ends up being what we call the point slope formula. The only difference is that you can actually change some of these numbers around. So instead of calling it y2 minus y1, we're just going to call it y minus y1. And instead of calling it x2 minus x1, we're just going to call it x minus x1. Okay? But you can see very easily that this formula comes literally from the slope formula. So this guy is what we call the point slope formula. And its name tells you exactly what you need in order to use it. You can use this point slope formula anytime they ask you to write the equation of a line, which lo and behold, this section is called writing linear equations. So the cool thing about this formula is that you can use any point and a slope. So as long as you know the slope and as long as you have a point that was given, then you can use this formula to write the equation of a line. And usually what you want to do is start with this formula and then end up in what we call slope-intercept form. And believe it or not, this is the one that most people oftentimes forget. But this is the one that leads up to the next one. And the next one is the one that most people always remember. And that's the so-called y equals mx plus b. That little guy is called slope-intercept formula. And I'm going to show you right now with my little graph over there why that's called slope-intercept formula. So we said earlier that this formula is based on 2 points that you have in the line. That's how we got the slope formula in the first place, is by finding the change in y or the change in x. So what I want to do right now is suppose that instead of having just any random point, suppose that you actually had a very specific point, in fact, the y-intercept. We learned already from standard form that when you have the y-intercept, the x-coordinate is always 0. So I'm going to go ahead and use this point 0b. 0b is going to represent why can't I think here? It's going to represent the y-intercept. B is going to be any y value that's crossing on the y-axis. And of course the x-coordinate has to be 0 because otherwise it wouldn't be the y-intercept. So when you specifically have the y-intercept, then this formula simplifies. So we have this point over here, and this point is not the y-intercept. So for that guy, we're just going to call that one x2, y2. All right? Or even x1, y1 if you want to. Okay? So we're just going to call this guy x1, y1. Okay? So what happens when we plug in these numbers into this little guy? First, we have to know the slope. Right? We need this little guy. What is the slope of this little guy here? We already know from before that we have to name these by something, right? So I already called this x1, y1, so I'm going to go ahead and call this one x2, y2. As long as I'm consistent, it doesn't really matter. So I'm going to calculate the slope real quick for this guy. And the slope is going to be y2, which is b, minus y1, which in this case is just y1. Right? And then I'm going to go on the bottom, and I'm going to call this little guy, let's see here. Actually, we don't want to do that. I'm so sorry. Let's back up here. That's just going to confuse you more. We don't want to confuse people. We want to clarify things for people. So let's just call M what it is, M. Okay? Let's not even go there. Let's just call M M, okay, for this whole purpose here. So I'm going to take, I want a different color. What color do you guys want? Green? Okay, good. All right, so let's plug in to our formula. What is y minus y1? Okay? What is the y value here? Anybody? Anybody?
6.
B.
Oh.
Okay? We're going to put here, this is my x1, y1, x2, y2, right? If you label everything. So y minus y1 is y minus b because b is in the y1 spot. We're going to leave the m alone. And then we're going to go x minus, what's x1? x1 is 0. Huh, Kit?
Yes.
Yes. So then what happens? Let's simplify this little guy. M times x is mx. M times 0 is 0. And the last thing you want to do is add your b to both sides. And voila. You get that y equals mx plus b. Isn't that gnarly? That's your second formula. This is called the slope-intercept formula. Slope-intercept formula. So unlike the point-slope formula, both of these formulas require that you know the slope. They both have slope in their name. The difference between the two is that the slope-intercept requires that you know what the y-intercept is. In the case of point slope, it doesn't have to be the y-intercept. It could be any point that you want. It works for the y-intercept, but it could be any other point. This one, you only want to plug in the intercept into it. So again, we're generally going to start with point slope to get the process going, and then eventually we will simplify it to get slope-intercept form. And we will talk about that as we go through the examples. Those are the two formulas you need to have. So here's our example. It says write an equation in slope-intercept form. So see, they want this to be in y equals mx plus b. But before we can get there, we have to make sure that we have the y-intercept. So we have to know what the slope is, and we have to know what the y-intercept is in order to plug it into y equals mx plus b. Because in this formula, the m represents the slope, and the b is the y-coordinate of the y-intercept. So as I look at my graph, it is actually pretty easy to tell that the y-intercept, the place where it crosses the y-axis, is right here. And we're going by ones. This is a -5, so make sure you're reading your scale. -1, -2. So that means that my y-intercept is actually 0, -2. But then I have to figure out what my slope is. Okay, so my slope, there's a couple of ways that you can do that. When you have a graph, you can just kind of count. If I'm going to go up 2 and over 1, 2, 3, 4, 5, 6, like that, you could do that. Or you can use 2 points to actually tell you what the slope is. So I am going to go ahead and just go, let's see here, 1, 2, 1. It looks like it's -1/2. But let me confirm that with my textbook. Again, if you don't like the way the graph looks, my graph kind of looks funny. But if you actually look at your textbook on page 84, they have a better graph. And it looks like we have 0, -2, which I already got, and -4, -1. So 1, 2, 3, 4, -1, right here. That point right there. The coordinates of this point are -4, -1. Okay? So now using these 2 points, 0, -2, I am going to find the slope. The slope is going to be, first label, x1, y1, x2, y2. So according to the slope formula, we're going to go -2 minus y1, which is -1, so minus a negative is a plus. And then x2 is 0 minus -4 is a plus. Remember, minus negative is a plus all the time. And we're going to get -2 plus 1 is -1. And 0 plus 4 is 4. So our slope becomes -1/4. So now it's very simple to plug into y equals my slope, -1/4 x plus b, which is the y-coordinate of the y-intercept. So there you go. Y equals -1/4 x minus 2. It's very simple when you have the y-intercept. So now you are going to try, these 2 questions right here. the slope is given in this guy, and the point, this is the y-intercept because the x-coordinate is 0. But over here, it's kind of like the one that we had where the slope is not given to you directly. This is the y-intercept because the x-coordinate is 0. But you have to use these 2 points to find the slope first, and then you can continue. All right, so then we have this little guy. And what you see here is that I have the slope. I'm told that the slope is -4, but this is not the y-intercept. So now this is not going to be y equals mx plus b, x1, y1, okay? I'm going to label my point, but now we're going to have to use the point slope formula because I don't have the y-intercept. So I'm going to go y minus y1, which is -2, so minus a negative is a positive, equals my slope, which is -4, times x minus x1. So then I get y plus 2 equals -4x, negative times negative, positive, 6 times 4, 24, minus 2, and you get y equals -4x plus 22. So don't be mistaken that just because I started by using the point slope formula, eventually you do want to end up in slope intercept form, which is y equals mx plus b. But you want to start here when you don't have the y-intercept. So in this case, I did not have the y-intercept, and that's what I did with that guy. So this example, you will see that here they gave you the slope. This is not the y-intercept. Again, they gave you the slope. This is not the y-intercept. So in these two examples, you should be starting with point slope formula and then simplifying to slope intercept form because they do want the answer in slope intercept form. All right. And this is going to be our last, I think, example. Let me confirm that here. Nope, I lied. I'm a little liar, sorry. I forgot about parallel and perpendicular. But this is a question that kind of confuses people sometimes, but it's not that complicated. We still want to write the equation of the line, but this time they're giving us 2 points, neither of which is the y-intercept because neither of them have an x-coordinate that's 0. Boo-hoo. But we can calculate, this is just a bit more work, but it's not very hard. What we have to do in this case is calculate the slope because they didn't tell us what the slope was, but because we have 2 points, we can just label them and we can figure out what the slope is. So according to the slope formula, we're going to go y2, which is -3, minus y1, which is 7, x2, which is +3, minus x1, which is -2, so minus a negative becomes a plus. -3 minus 7 is -10. 3 plus 2 is 5, and you get -2. Yes, yes. So now I have my slope right here, and I already have my points labeled, so I can now proceed to use the point slope formula, which is y minus y1, which we already said is 7. And now I know my slope is -2. And then x minus x1, which is -2, so minus a negative is a plus. And we can just simplify this to get the equation. So y minus 7 equals -2x minus 4. Distribute here. And I add 7, so we get y is equivalent to -2x plus 3. All right, so that was created a little bit more of a problem because we didn't know what the slope was off the top of off the bat. But you can find it very easily by using the slope formula. And then we used the point slope formula and eventually simplified it to the slope intercept formula. Coolness. So now, that's your little guide. Again, not the y-intercept. And you need to find the slope first and then you can continue. But here we go. Parallel and perpendicular lines. It's kind of funny, non-vertical lines. That means that vertical means like straight up and down, right? Like, there you go. The reason why it specifies that it's not vertical is because vertical lines don't have a slope. The slope of a vertical line is undefined. And therefore, we want to talk about all lines that are vertical lines. Like I said here, all vertical lines are parallel to each other. So if there's multiple vertical lines, whoa, crazy bell. If there's multiple vertical lines, they will all be parallel to each other. And any vertical line will be perpendicular to a horizontal line, which is kind of what it says here. But aside from vertical lines and horizontal lines, then everything else under the sun that has a diagonal like this or like this, all the other kinds of lines, we know that they will be parallel if they have the same slope. Okay? So parallel means same slope. Perpendicular, if you have two perpendicular lines, then the product of their slope, so product of their slope will be -1. A lot of people don't like the way that sounds. Product of their slope is -1. Another way of thinking about it is negative reciprocals. For example, if I have a problem that the slope is 2/3, then another equation can have a slope that is the negative reciprocal of that. Then that would equal negative, because this is positive, and then the reciprocal would be 3/2. So that's what that means. If you are going to be perpendicular, then the two slopes that you have are negative reciprocals of each other, which is kind of what I put right here. But another way of saying that is that when you multiply 2/3 with -3/2, you do in fact get -1. 2 times -3 is -6. 3 times +2 is +6. -6 divided by positive is -1. So the product of their slopes will be -1. But another way of saying that is that they're negative reciprocals of each other. That means that if one's positive, the perpendicular one will be negative. If it's negative, the perpendicular slope will be positive. So just something to note there. So here we have our example, and it says write an equation in slope-intercept form for the line that passes through. So we have our point. They are telling us that this is x1, y1. By the way, this is not the y-intercept because the x-coordinate is not 0. And we know that it has to be perpendicular to the line with the equation y equals -3/2 x plus 7. Now let me just tell you briefly here what's happening. You have a graph. Somewhere on the graph there's a line. And this is not the exact line, but this is kind of what it looks like. It's going to have a negative slope, so it's going to be looking down. And then this point, 5, -6, is going to be over here somewhere. The point 5, -6 is not on this line. Okay? What they're asking you to do is they want you to find the equation of a line that is perpendicular, crosses at a 90-degree angle, perpendicular to the blue line, but that passes through this point. That's what they want you to do. Now, you don't have to graph all that to understand what to do, but I just wanted to give you guys an idea of what it exactly is that they're asking you to do, okay? So what we do for this is if we know that it's going to be perpendicular to this line, then that means that my slope, my perpendicular slope, has to be the negative reciprocal of this slope. So if this slope is -3/2, then my slope must be positive 2/3. So indirectly, they are telling me that the slope is 2/3, and the point that I'm passing through is 5, -6. Once you have those two pieces of information, you can carry on like usual. I'm going to say y minus y1. So minus -6 is a +6. The slope is going to be 2/3. X minus 5, because 5 is x1. And then I just simplify. So y plus 6 equals 2/3 x. And 2/3 times -5 is -10/3. And then I'm going to subtract 6 right here. And my final answer will be that y equals 2/3 x minus, I'm pretty sure that 6 is 18/3. Is 18 divided by 3, 6? Yes, so this is 18/3. So -10/3 minus 18/3 is -28/3. So basically, this equation that I just came up with is going to be perpendicular to this one and passing through 5, -6, as I have done all my work correctly because I am cool that way. Okay? So now, what we are going to do is ask you to do something similar. Let me see here. And this will be your last example. Same thing that we just did here. But be careful. I should have said the same thing. Don't get all carried away and not read the problem. This is almost the same. In this case, it's asking for a parallel line. So the slopes will not be negative reciprocals of each other. The slopes will be the same. So aside from that, it is the same thing as the previous example. And once you have completed that guy, yes, just making sure, then you will have done your notes for today. And I will see you in class, and thanks for watching. Oops.